Alright, so we've had our basic graph of y equals tan of x sitting right here for us. So it had a period of pi, intercepts and points of inflection at multiples of pi, asymptotes at integer multiples of pi on 2, and a key point of pi on 4 and 1, and finally it was centered about the x-axis, or y equals 0. Now we're just going to take a look at one transformation of tan. So we looked at a, n, and k for cos and sine, but for tan we're actually just going to take a look at n for now. So what that's going to do when I put a horizontal dilation in here, what that's going to do is change our period to pi over n. So if it was, say, tan of 2x, my period would be pi over 2. That means that the points of inflection, or x-intercepts, are now going to be at integer multiples of pi on n, so multiplying each of those by integers. And then the asymptotes are, again, at integer multiples of pi on 2n. So that's going to help us to sketch out our graphs. So once we know what our period is, we'll put on our asymptotes and we'll use that to draw a basic sketch of the graph. So we're going to sketch these three graphs today. We're going to start with y equals tan of 2x. So for this graph of y equals tan of 2x, our period, so again, is pi on n. So in this case, n is 2, so our period is going to be pi over 2, meaning it's going to repeat double as often, so it takes half as much time for it to repeat. The intercepts, those are again going to be, in this case, at integer multiples of pi on n. So in this case, one of them will be at pi on 2. If I take pi on 2 and multiply by 2, that will be at pi, 3 pi on 2, and so forth. And then I can also go back in the negative direction. That would be at 0, negative pi on 2, etc. So again, that's taking negative 2, negative 1, 0, 1, 2, dot, 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 and multiplying that by pi over 2. So 2 times pi over 2, well, that's just going to give me pi. 1 times pi over 2. So each of those is just taking integers and multiplying by pi over 2 and simplifying if necessary. Now my asymptotes, those are again going to occur double as often. So they're going to cover half the span. So in this case, again, taking integers, but in this case, multiplying by pi on 2n. So in this case, pi on 4. Sorry to jump the screen there. So in this case, because n is equal to 2, my asymptotes are going to occur at negative pi on 2 times 2. Well, that would be negative pi on 4. Negative pi, sorry. So my next one, pi on 2n. That's pi on 2 times 2, which is pi on 4. The next one, 3 pi on 2n. So that's 3 pi on 4. So again, this is taking multiples, essentially, of pi on 4s. Notice each of these are pi on 2 apart. So that's consistent with my period. And now it's just a matter of doing a nice sketch. So I'll start by putting on a scale going up by pi on 4s, because that will account for these as well, because those are just the even multiples of pi on 4. So I'll grab my pencil. So we've obviously got, we start at 0, and then we've got pi on 4. The next will be pi on 2, 3 pi on 4, pi, 5 pi on 4, so we're just going to go up to 2 pi here. This will give me 3 pi on 2, because that would have been 6 pi on 4, which reduces to 3 pi on 2, 7 pi on 4, and then finally 2 pi. It's a little bit squished in there. If you had just labeled every other one and put the tick, that would be okay as well. So my asymptotes are the multiples of pi on 4 that aren't pi on 2's. So, of course, you'll get out a nice ruler and draw these dotted lines on. I'm going to do the best that I can. So at pi on 4, drawing on an asymptote, then again at 3 pi on 4, 5 pi on 4, 7 pi on 4. Oops. Sorry, that's pretty dreadful drawing. And then I'll go ahead and start actually drawing my graph. So I'll draw that in red. So my intercepts were at negative pi on 2, 0, pi on 2. So I'm going to have all of the ones where we didn't have asymptotes, we're going to have intercepts. Again, my behavior from 0, the graph starts going up. Again, use arrows to show that it continues. And then remember, think about the unit circle. It all of a sudden switches to negative. So it drops way down here, comes up to 0, oops, wiggle there, and then continues up. Again, drops down to negative, goes up through the 0, goes up through the 0, and then here again, this part will just be half of it. And that's my basic shape of y equals tan of 2x. Over here, I just did 0 to 2 pi. Obviously, I could have kept going in the opposite direction if I had chosen to do so, or been asked to do so. Okay, so now let's take a look at changing the period going the other way. So looking at tan of x on 2. So this means that it's going to, only half of the graph is going to show over the typical period, so it's going to take double as long to do the full graph. So let's have a look at that one. Alright, so having a quick look at tan of x on 2 rather. So my period here, well that's pi over 1/2, which again, when I'm dividing by a fraction, that's multiplying by the reciprocal. So now the period's going to be over 2 pi. So it's going to take twice as long, or you can think of it as half of the graph is shown within the typical period. So that's our period. The next thing we want to consider are our intercepts, our x-intercepts. Okay. So again, these are going to happen within the period of 2 pi. So just to refresh, the intercepts occur at multiples of pi on n. Okay, so that's the same thing as the period there. So that's going to give me pi over 1/2, which we've stated is multiples of 2 pi. So again, it might help you to think about listing out a few integers. Got a little excited there, started writing out the answer. Let's try that again. Listing out a few integers. 1, 2. If I was to take that list and multiply it by 2 pi, I'd get negative 4 pi, negative 2 pi, 0, 2 pi, 4 pi, and so forth. Okay, so taking integers and multiplying it by that pi on n. So I'm going to have basically x-intercepts at every even pi, and 0. So negative 4, negative 2, 0, 2, 4, 6, and so forth. That's where I'm going to have my x-intercepts. And my asymptotes are going to occur in between those. Okay, so my asymptotes, again, the cheeky way, once you've already done this, well, they occur halfway in between those. So they're going to occur at negative pi, pi, 3 pi, and so forth. So that's my basic key features of the graph. So I've got my period is 2 pi, the x-intercepts are the even pi's, and the asymptotes are at the odd pi's. So now I can start sketching my graph. Draw up some axes. put on my asymptotes in a light green. So we'll start by putting on pi, 2 pi, 3 pi, 4 pi. Just for fun, let's go in the negative direction for one cycle as well. So we'll go negative pi and negative 2 pi. Okay, so my intercepts occur at the even multiples and my asymptotes occur at the odd ones. So I can start putting on my asymptote, so it's going to occur that side, there. And then when I start actually drawing my graph, again I'll do that in red, I can put on my zeros, my points of inflection. I like to start with the 1 at 0 because I know it starts by going up. Oops. Switches to drop down negative. Sorry, these are dreadfully ugly graphs. Use the CAS to get a better picture. It's going in the negative direction, switches to positive. Okay, so this is our graph of y equals tan of x on 2. Okay. Now we will create a separate video for our last example, which is sketching the graph of tan of pi x.